Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this graphing problem using the concepts of derivatives. So as per the problem, sketch a graph of a function that is differentiable on the interval -2 to 5 and that satisfies the following conditions. The graph of f passes through the points -1, 0 and 2, 5 and the function f is decreasing from -2 to -1, increasing on -1 to +2, and decreasing again from 2 to 5. Now there are a few things we have to keep in mind before we start graphing this function. A function is differentiable if there is no vertical asymptote, no jump in the graph, or no cusp point in that interval. So that's one important thing we need to understand about this problem. Now we are given 2 points that lie on this function -1, 0 and 2, 5. So now we can plot these 2 points. So we can plot the first point as -1, 0, which is the point on the x-axis, and then the other point is 2, 5. Now the next information we are given is the function is decreasing from -2 to -1. So if the function is decreasing from -2 to -1, that means the slope of the tangent to the function in this interval is negative. That means the tangent that we draw to this function from -2 to -1 will slope downwards from left to right. That means from the -2 to -1, the graph is sloping downwards. So we can draw the graph like this from -2 to -1. Now keep in mind that here we are just sketching this graph. So not all points that we show on this graph will be exact points. So be like this. Now we are given that the function is increasing from -1 to +2. Now see, we are given that the function is decreasing from -2 to -1 and then increasing from -1 to 2. That means there is a change in the direction of the function at x equals -1. So that means we have to show that the graph goes up from -1 to 2, and at x equals 2 we are given that the function passes through this point 2, 5. So that means any tangent that we draw to this function between -1 and 2 should have a positive slope because this function is increasing from -1 to 2. So that means the graph from -1 to 2 will look something like this. So any tangent we draw to this graph from -1 to 2 will have a positive slope or upward slope from left to right. Now the function is decreasing again from 2 to 5. So again there is a change in this function at x equals 2 because to the left side of 2 the function is increasing, but to the right side of 2 the function is decreasing. So that means at 2 the function starts going down. So x equals 2 here represents the local maximum in this case. So to the right side of 2 we can draw the graph like this. Now here we are given that the function is differentiable from the x values -2 to 5. That means we should end our graph at 5. So again we don't know the points, the endpoints of this graph on the left side and the right side. So the most important thing is to just show that the graph starts at -2 on the left side and ends at 5, the y values of these 2 points doesn't matter because we are just sketching this graph. So these are the steps you have to keep in mind to draw a graph like this one from this type of information. So it's very important to understand that the concept of differentiable means that there is no vertical asymptote, jump, or a cusp. And in this case, this is why we show our graph starts at x equals -2 and ends at 5. We don't know what happens to this function beyond those 2 points. It may not be differentiable. And then we show the 2 points that lie on this function, and then we sketch the parts of the graph based on the given intervals on which it is increasing and decreasing. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.